So right now, I just want you to follow along with me on this. Okay, so let's. You think you know the whole thing now? Okay. It's okay. All right. So remember, y'all, we're all supposed to join my Quizlet class. If you ever did that, you're going to have to scroll back through all the updates in Schoology, find it, make sure you do that. I don't know that I've put anything in there yet, and I will double check after school, but I have some flashcards for the unit circle to help you. And with Quizlet, if you're not very familiar with Quizlet, you can use it as straight up flashcards. Quizlet will do little games for you based on your flashcards, whatever. There's an app on your phone. So it's something that would be easy for you to do. And then there's also another little game that's on a website called Purpose Games or something like that. I will send you a link and remind today after school. I feel like there's 11 of you in here. There's only 10 of you signed up for my remind. So I don't know who that missing person is, but you're not going to get the stuff if I don't give that to you. So if you're too good to be in my remind, I don't know what to tell you. And so, but I want to go through this. I want to help you kind of think around it real quick as a quick review before we get into what we're doing today. So here's what we know in degrees. We know that this is 0, right? We know that this is also 360. Oh, 360. This is 90, or what is this? Isn't 90. I told you. Just follow along with me. It's not on there. 180. It's not 90. You also have to stop me. The wrong. My mouth don't always agree. This is 90, and which means this in degrees is how much? 270. Okay. And then your special angles in here come from your special right triangles, actually. So you have 3 special angles. Do you remember special right triangles? Do you remember what they were called? Or what angle went with them? Everybody. Okay, 45, 45, 90, 30, 60. So we have 45, 45, 90, 30, 60, 90. So that 30, 45, 60, those are still our special angles, okay? Which means that here, halfway between 0 and 90, 45 degrees, right? And then this is a third of the way, so this is 30 and this is 60. Tomorrow, y'all better not be absent tomorrow because we're going to do the unit circle. It's a very cool activity. It is important for you moving forward. You're going to enjoy it. You'll learn a lot from it. There's a whole lot going on there. Okay, so then that means that each little section here is 30 degrees, right? So if this is 90, that makes it 120, right? And then not each little section. They're not actually spaced the same, but this is 120, and this is 150 because this is a third, this is another third, this is halfway. So halfway between 90 and 180 would be what? 135. Okay. And 180, so this is 30. 180 plus 30 is 210, right? Plus another 30. Oh, am I missing a point on there? Oh, what happened to my point? Oh, no. Well, no, what I'm thinking of is, oh, my God. Oh, okay. Oh, that makes me feel better because this is on a quiz I gave my kids today. Or is that point missing? Oh, it is missing on some of them. Oh, my Jesus. Okay. It's 240. I don't know what happened to it. So that makes this 300, 330, and that's where we get to 360, right? So if this is 180 and I got to go 45, this would be what? 225. And 270 and I go 45, that's going to give me 315, right? Right, so those are all my degrees. Right now, you're way more comfortable thinking in degrees than you are in radians. But I'm going to show you how the radians are way easier to think through, okay? There's patterns in there that really aren't there very much with the degrees. So let's take the degrees away. And then we're going to talk radians. I know that this is 0. 1 full rotation in radians is how much? 2 pi. So halfway to here, or halfway around would be pi, right? So then halfway between and pi is what? Pi, which is pi halves, right? So if we think in halves, right? I've got 0. This is 1 pi over 2. 2 pi over 2 is pi, right? So this what? 3 pi over 2. And that's 4 pi over 2. That's where 2 pi comes from, right? And that's as much as we labeled in radians yesterday. But let's see, halfway between 0 and pi halves would be what? Okay, let me ask you this. Let's because here's some other things that you should have known forever. I think you realize you just love in math. Not necessarily. Of it's a computation symbol. Let's see, I want 1/3 of 60. Well, tell me, what is 1/3 of 60? 20. Mathematically, what would I do with 1/3 and 60 to get 20? Multiply them. Of means multiply. Okay. Of means multiply. So if I want half of 1 pi halves, then half of pi halves gives me what? A fourth. Half of a half is a fourth, right? Think about, you divide something into half, and you divide half again, you get a fourth. So halfway between 0 and pi halves is pi fourths. Okay, you with that? So now let's think in fourths. This is what I meant when I said you have to be able to think fractionally. So I'm here at 0. This is 1 pi fourths. Yes? This is 2 pi fourths, which is pi halves, right? I go another 45. That is going to be how many pi fourths? 3 pi fourths. Then this is 4 pi fourths, which is pi, right? This is going to be 5 pi fourths. This is 6 pi fourths, which is right. And here, this is going to give me 7 pi fourths. And then 8 pi fourths, which is 2 pi. So do you notice how all of the points that are halfway there have the fourths in them? Right? Okay, so let's talk 60. From 0 to 180, okay, if I think of from 0 to 60, how much of 180 is 60? A third. So I want a third of pi. What would this be here then? What's a third of pi? Pi over 3. If 180 is pi, then 60 is pi divided by 3. Does that make sense to you? Okay, so I'm here at 0, 60. I go another 60, which gets me here. That's going to be 2 pi thirds. I go another 60, that's 3 pi thirds, which is pi, right? I go another 60, that gets me 4 pi thirds. I go another 60, I get 5 pi thirds. I go another 60, well, you're going to have it all tomorrow. You'll write this a bazillion times. Right now, I just want you to see it so you don't miss anything because you're writing, okay? So then 6 pi over 3 would give me 2 pi. Make sense to you? Okay. So then we look at the 30s, right? Well, 30 is half of 60. Do we agree with that? So 60 is pi thirds. What is half of pi thirds? Pi sixths. So this is pi over 6. So now I'm going to do my 30s. From 0 to 30 is 1 pi over 6. This would be 2 pi over 6, which reduced to pi thirds. 3 pi over 6, 4 pi over 6, and then 5 pi over 6 doesn't reduce. 6 pi over 6, which is pi. 7 pi over 6. 8 pi over 6, which is this. 9 pi over 6. 10 pi over 6. 11 pi over 6. 12 pi over 6. Now just look at this in the different colors. I wish I had put these in a different color here, so kind of ignore those right now. Do you see how the purple ones have 6 in the denominator, close to the x-axis? All the thirds are green, they're all close to the y-axis, and all the 4s are right in the middle of the quadrant. And if you learn the first quadrant and you truly know them, there's so many patterns here. That's why it takes a little bit at a time. We took this stuff and we the middle of the trig unit and we put it at the beginning because you've got to learn it. And it takes some time to marinate in your brain, and it takes some practice. And so we got to practice and really, really learn it, because if we teach it really where it goes, then the next you're expected to know it 100%, and you're not going to, okay? And if you memorize it all for a quiz the next day, you'll forget it right after. We want to learn it and understand how it works, and you'll be way better off, okay? We all good with all that? Okay, so a little bit of review from yesterday and a little preview for tomorrow, and let's look at what we're actually doing today then, which is our trig functions that goes along with all of this stuff. And I believe this is going on 83. Does that sound right? I forgot by now. 83, yes. Okay. So, trig functions. Trig is introduced to you in geometry. Trigonometry is just literally means triangle measure in the Greek words. And so trigonometry is the study of the relationships among the side and angle measures in triangles. Ratio in math always means what? Fraction. Ratio means fraction. Okay, so set up a fraction. A trigonometric ratio compares the lengths of two sides with respect to an acute angle theta. That's why we look at the Greek alphabet. A trigonometric function is the rule defined by the trigonometric ratios. So sometimes I use those words interchangeably, like which trig ratio do we need or which trig function do we need? It's the same thing. But the difference between trig ratios and similar triangles, because you've been doing similar triangles for a long, long time, all the way through junior high. So with similar triangles, you look at this side of this triangle corresponds to this side of another triangle, and you set up proportions, right? Trig ratios is just ratios of two sides of the exact same triangle related to an angle, all right? And then we have, scale factors, things that go along with it. You learned 3 trig functions in geometry. You learned sine, cosine, the other 3 or 3. Remember that they're all related. Theta angle that you're using, use either one, but like this is what we're talking about. Opposite the angle is hypotenuse. Okay, now listen, the hypotenuse, yes, it's the longest side, but that is not how it's defined. Because if nothing's labeled, how do you know it's the longest side? Because it looks that way, it doesn't work that way. And it's also not the slanty side, because I could turn a triangle, make any of them slanty, right? The hypotenuse is defined as being the side across from the right angle. That's why it's the longest side, okay? So you've got the side opposite the angle, which is the opposite side. Always the hypotenuse. And then you have the adjacent. So the theta adjacent side is adjacent to it. The hypotenuse is adjacent to it also. But it's the fact that it's the hypotenuse is important. Along with trig that helps you remember how to set up these ratios. Who can tell me what that is? So very good. So SOH, CAH, TOA. Okay? So good. Maybe we have time today. The song, I have the song, but not have time today. So in order to do this, what this means, in case you don't remember, but you totally should have learned this, is that we have sine, cosine, and tangent. They abbreviate like this. It is not sin, cos, and tan. Do not even bring that junk into my classroom. It is abbreviation. With any abbreviation, you say the real thing, okay? The example I always use is, let's say you go to the doctor, and your doctor's name is Dr. Smith. When he walks in the room, do you say Dr. Smith? No, because you sound like a moron, okay? Same thing. This is an abbreviation. Sine, cosine, and tangent. Right? So, yeah. So, sine of theta. That's how we read this. Sine of theta. Sine, this means it is opposite over hypotenuse. That's what this tells me. So, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, so then the other 3 that should be new to you are cosecant, secant, and cotangent. And those are just reciprocals of the first 3. So you have to make sure that you connect them to the correct ones. Sine and cosecant are reciprocals of each other. Okay, so that means cosecant, since sine is opposite over hypotenuse, it's hypotenuse over opposite. Secant is the reciprocal of cosine, which means it will be hypotenuse over adjacent. And cotangent is the reciprocal of tangent, and that gives you adjacent over opposite. So it's pretty easy to remember because sine, cosine, and tangent should be the ones that you're already familiar with. So the other ones are reciprocals of those. Cotangent and tangent go together. Those kind of make sense, which makes you wonder, why doesn't sine and cosine go together and cosecant and secant? Just because they don't. But when you look at how things are set up, each pair only has one co in it. So it's sine and cosecant. It's cosine and secant. It's tangent and cotangent. So if you recognize that, it's pretty easy to keep together which ones go with which. Okay, we all good with that? All right, good deal. So it says, because the cosecant, secant, and cotangent ratios are reciprocals of the sine, cosine, and tangent ratios. They are called reciprocal functions. So they can also be defined as, well, cosecant of theta is the reciprocal of sine, so it's 1 over sine theta. Secant of theta is 1 over cosine theta. And cotangent of theta is, back that up, I'm writing the wrong thing, is 1 over tangent theta. Okay. Everybody okay with all of that? Any questions? All right, so we're not going to do every single one of these things, but we are going to do a few, and we're going to do a few with some square roots in them. So it says find the exact values of the 6 trigonometric functions of theta. So another word for a trig function is a trig ratio. It's asking me for exact values, which means I ain't touching a calculator because it's not going to give me exact values. Second thing is, nobody's asking you to solve for anything. Nobody asked you to solve for a side. Nobody asked you to solve for a theta. We are just setting up the ratios, which are the 6 trig functions. So I look at number 1. I'm going to label my triangle. Here's theta, right? So across from theta, this is my opposite side. Across from the right angle is the hypotenuse, and this is the adjacent. And I would highly suggest, if trig seems a little foggy to you, that you label that every single time. Okay? And then you should get to a point where you don't need to anymore. Sine of theta. Okay? And you also may need to rewrite SOHCAHTOA multiple times until you get the hang of it again. And then it can just kind of be in your mind. But it doesn't do you any good if you don't spell it correctly. Okay? That's kind of the whole point of it. So sine is opposite over hypotenuse. So that means I'm going to put 12 over 13. And then I reduce if I can. I can't reduce. That's my ratio. Cosine is adjacent over hypotenuse. So it's 5 over 13. Tangent is opposite over adjacent. It's 12 over 5. And none of those actually reduce. So cosecant is reciprocal of what? Sine. So instead of 12 over 13, it would be 13 over 12. Secant is the reciprocal of cosine, which would give me 13 over 5. Cotangent is the reciprocal of tangent, which is 5 over 12. Okay. Easy enough? Okay, so if they don't reduce, they're super easy. Like you just set them up and boom. Some of these are going to reduce. Some of them are going to have some square roots in them. They need to do a little bit of different stuff. So let's look at number 2. Here's my theta. So this is my opposite side. This is the hypotenuse. And this is adjacent. So the sine I know is opposite over hypotenuse. So I can put 4 over 4 square root of 5. What happens to the 4s? They cancel out. Does that leave me with the square root of 5 in the end? No. That leaves me with 1 over the square root of 5. Is that legal? No. I knew it. Why is it not legal? You have a square in the denominator. So what do I do to get that out? By square root of 5 over square root of 5, right? I rationalize the denominator, which would give me the square root of 5 over what? Here, okay. I'll write it out this one time, but I'm not writing it every time. 5, it is. But so I multiply by the square root of 5 over the square root of 5. That's what I'm doing, but I'm only writing that one time. And so from now on, we just got to know that's what's happening. That gives me the square root of 5 over 5. Okay, everybody good with that? So then cosine of theta is adjacent over hypotenuse, so that's going to give me 8 over 4 square root of 5. So then I cancel this out. Our 8 and 4 reduce, and I'm left with 2 in the numerator, right? I still have a square in the denominator. That's bad. So I rationalize and get what? No, I get 2 what? Square root of 5 over 5. Okay. Then tangent of theta is opposite over adjacent, so that is 4 over 8, and that reduces to 1/2. Okay. Everybody okay with that? So now I move on to cosecant. Well, cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. It is 4 square root of 5 over 4. Those 4's cancel out, and what am I left with? square root of 5. I could also just take the reciprocal of sine, but if I were going to do that, I want to do that the smart way, meaning I don't want to take the reciprocal of this because then I have to rationalize. If I take the reciprocal of this right here, doesn't that give me the square root of 5? Right, same thing, and it's already reduced for me. So secant is the reciprocal of cosine. If I take this reciprocal, I'm putting the square root in the denominator. That's bad. But here, so I take the reciprocal, I get square root of 5 over 2, and I'm done. Cotangent of theta is the reciprocal of tangent. What's the reciprocal of 1/2? 2. I'm done. Okay, everybody okay with all that? We good? All right, we're going to do number 4 just to make sure we really are good with this. Okay, so well, goodness, I don't even have my hypotenuse here, right? So I've got to figure that out. How do I find the missing side of a right triangle? Pythagorean theorem, okay? A squared plus b squared, yeah. All right, so Pythagorean theorem, I'm looking for the hypotenuse, that's c. So this is 6 squared plus 6 squared to 3 squared equals x squared. I'll call that x to get it. So did I write all this down correctly? No, I actually missed something here. I need parentheses. Because if all I do is square that square root of 3, that's bad. And if you try to type that into the calculator when you're not in here, you're probably going to get the wrong answer because 99% of the people that do that type it in wrong. And so it gives you the wrong answer, but you don't know that because it's what the calculator said, so it must be true. So 6 squared is 36 plus, when I square 6 squared to 3, square the 6 and get what? 36. Square the square root of 3 and get what? 3. Okay, so it's 36 times 3, and then that equals x squared. And you wouldn't necessarily have to write this up. I just want to make sure everybody knows where that's coming from. So this gives me 36 plus, what's 36 plus, times 3? 108 equals x squared. So 36 plus 108 is 44. Good. That means that x is equal to 12. Okay. So the hypotenuse there is 12. So then here's my theta. This is the opposite side. This is my hypotenuse. This is adjacent. Okay. Everybody. So then I'm going to figure out my ratios here. Sine of theta is opposite over hypotenuse, so that's 6 squared to 3 over 12. Okay. And what does that reduce to? Square root of 3 over 2. Good. All right, so cosine of theta is adjacent over hypotenuse, so that's going to be 6 over 12. That reduces to 1/2. Tangent of theta is opposite over adjacent, so that's 6 square root of 3 over 6, which gives me square root of 3. All right, so then my cosecant. Cosecant is the reciprocal of sine. So this one is the better one to use here. So I get 2 over the square root of 3. Am I allowed to leave it like that? No, I've got to rationalize. What does it become? 2 square root of 3 over 3. Secant is the reciprocal of cosine, so that's just 2. Cotangent is the reciprocal of tangent, so that would be 1 over the square root of 3, which becomes what? Square root of 3 over 3. And then let me ask you this. Looking at number 4, I don't expect on the other ones for you to be able to tell me what theta is without a calculator or some more information. But on number 4, you should be able to tell me what that angle measure is. Anybody know? Okay, I heard 45. If it was, anybody else think it's 45? If this was 45, it would have to be true about these sides. So it's not 45. So you have the S, 2S, S squared 3 relationship. Is this the long leg or the short leg? Long leg, so is this 30 or 60? 60 is across from the long leg, 30 is across from the short leg. So if you recognize that before you didn't have to do this was a 6 and this is 6 squared root of 3, this has to be 12 because it's a 30, 60, 90 triangle. Okay, and if you don't recognize, you do Pythagorean theorem, whatever. So that means then the sine of 60 is square root of 3 over 2. The cosine is 3 over 2. And those are values that you're going to have to know. Not right now, and I'll show you how you're supposed to know them and how you learn them, but I'm just kind of telling you. Okay? All right, let's look on the back. All right, so we're going to do 5 for sure. We're going to do 5 and 8 and fill in the bottom. So it says use the given trigonometric value to find the remaining function values. So I know that the tangent of theta is 7 over 24. So this is 7 over 24. So what else can you fill in? 24 over 7. Good job. Okay, 24 over 7. So the other things I can't do because I don't have enough information. Would you agree with that? So what I need to do is try and find that information. So I'm going to draw myself a triangle. I don't know what it's really supposed to look like, except it's supposed to be a right triangle. So that's good enough. And I'm going to make this theta. So if the tangent of theta is 7 over 24, I should be able to label two sides of this triangle. Can I label this leg right here? What would it be based on this information here? Good. Now what number can I put on that? 24, because this is opposite over adjacent. So this is the opposite side, which is 7. So I could put 24 here. Now, does this mean that these are the side lengths of that triangle for sure? No, this is like the reduced version, right? If I was to actually make them. But it's good enough to get me everything else because it's good that it's already reduced. It means I might not have to reduce it more. So if it's 7 and this is 24, what do I do to figure this out? Pythagorean theorem. So I'm going to do 7 squared plus 24 squared equals x squared. 7 squared is 49. What's 24 squared? You should know your perfect squares to 25. That's in the Quizlet 2. Practice them, okay? A good way to practice them is to just learn what the numbers are, meaning that you don't necessarily have to remember right now what 17 squared is. Just learn what the big numbers are. There's a finite set of them. They'll start to look familiar. You'll be able to come up with them better. It's 576. That's equal to x squared. Then I have to add, when I add these two, I've got a couple things I can do. I can add 50 and subtract 1. Or I could subtract 1 and then add 50. That's a little easier. What's 576 minus 1? 575. And I add 50 to that. What do I get? 625. So x squared is 625, which means x is what? 25. So now that I have that, I can fill in the rest. Right? The sine of theta is opposite over hypotenuse. What's the fraction going to look like? 7 over 25. Good. Cosine over what? 24 over 25, because that's adjacent over hypotenuse. Cosecant is the reciprocal of sine, so that's 25 over 7. And secant would be 25 over 24. Okay. Everybody good with all that? So let's look at number 8. Number 8 is the secant of theta equals 4. Well, secant is the reciprocal of what? Cosine. So since cosine is adjacent over hypotenuse, this would be hypotenuse over adjacent. Does that make sense to you? It's a whole number, so I can make it into a fraction. Looks like that. So then I'm going to draw my triangle. And this is theta. Or whichever one, doesn't matter. Hypotenuse over adjacent, so your hypotenuse is 4, adjacent is 1. Okay? I need to find my missing side. So this time I'm not looking for the hypotenuse. So it's 1 squared plus x squared equals 4 squared. So that gives me 1 plus x squared equals 16. So what does x squared equal? What's 16 minus 1? 15. All right. So then that means that x equals the square root of 15. Can I simplify that? Nope. So it's just the square root of 15. Since this is theta, this is the opposite, this is hypotenuse, this is adjacent. Sine is opposite over hypotenuse. So that is the square root of 15 over 4. Can I reduce that? Nope, I'm done. Cosine is adjacent over hypotenuse. 1 over 4. Can I reduce that? Nope, so I'm done. Tangent is opposite over adjacent. So that's the square root of 15 over 1, which is just the square root of 15. Cosecant is the reciprocal of sine. So that gives me 4 over the square root of 15. And can I leave it like that? No. So that becomes 4 square root of 15 over 15. You see how easy rationalizing is? Reciprocal of cosine and secant, which is 4. They actually gave me that. These two I could have filled in from the beginning. Then cotangent is 1 over the square root of 15, and that gives me square root of 15 over 15. Okay. Everybody okay with all that so far? All right. Now let's look at these special right triangles, these values that very soon you're going to need to know. It says angles of 30, 60, and 45 are used frequently in trigonometry. You can use your knowledge of the side relationships in special right triangles to find the values of trigonometric ratios. So let's talk about how to label these to solve these in geometry. I find my my smallest angle in a 30, 60, 90. Across from that, I can label that as S. This is 2S, and this other one is S times the square root of 3. When you learned it, your teacher may have used X, I think, for lots of reasons. So I use S. Make sure that you know that they're S's and not 5s, that you can read your handwriting and my handwriting. Okay, so then let's say that because these are just ratios, and basically S is like my scale factor, right? What if S is 1? If S is 1, the hypotenuse is 2, and this is the square root of 3. Does that make sense to you? For 45, 45, 90, these sides are congruent. So I don't use S's for those. I don't use X either. I use L for leg. L, what would the hypotenuse be? Anybody remember? L square root of 2. Which again, let's say that L here is 1. That means this would be 1, this would be 1, and this would be 1 square root of 2, which is just the square root of 2. Because basically I could use any number there. I could set these up and it would reduce out. If I go ahead and 1, everything's going to reduce out a whole lot better to begin with. Okay? So we'll set these up. Should be real simple and quick here. Sine of 30. Okay. So 30 degrees. The sine is the opposite over hypotenuse, so that's going to be 1/2. Sticking with 30, cosine is adjacent over hypotenuse. So this was my opposite, this is my adjacent, and this is my hypotenuse. And so cosine is adjacent over hypotenuse. That's the square root of 3 over 2. Tangent is opposite over adjacent. That's 1 over the square root of 3, which is not legal. That gives me 3 over 3. Actual answer. Cosecant is the reciprocal of what? Sine. So it's hypotenuse over opposite, which is 2 over 1, which is 2. Secant is the reciprocal of cosine. So that's 2 over the square root of 3. Not legal, so that's good. 2 square root of 3 over 3. Cotangent is the reciprocal of tangent. So what's that going to be? Square root of 3. I'd take the reciprocal there, so I don't have to square root of 3. Okay. I get with all that so far? So let's look at 45. Sine is, so I'll use this 45 here. So I'll use this one. This is the opposite. This is the hypotenuse. This is adjacent, right? So opposite over hypotenuse is going to be 1 over the square root of 2, which becomes square root of 2 over 2. Cosine is adjacent over hypotenuse. So what's that going to be? It's 1 over the square root of 2. It's the same thing, right? So 1 over the square root of 2. So you get square root of 2 over 2. Oh. Tangent is opposite over adjacent. That's 1 over 1. That's 1. It should make sense that for 45, the sine and cosine are the same because the opposite and the adjacent sides are the same, right? Cosecant is the reciprocal of sine. So what's the cosecant of 45? Square root of 2. Secant is the reciprocal of cosine, so it's the square root of 2. Cotangent's the reciprocal of tangent. The reciprocal of 1 is 1. Now look what happens with 60. When I do 60, this is the angle, so the opposite and the adjacent switch places. Right? That's what happens. It is opposite over hypotenuse. The opposite is now the square root of 3 over the hypotenuse, which is 2. What does match in my 30-degree row? Cosine of 30. You saw cosine of 30 and the sine of 60 same thing, because those are the two acute angles in that same triangle. So those are, and because we switched opposite and adjacent, it switched sine and cosine. So 60 for cosine, it's adjacent over hypotenuse. So that's 1 over 2, which is the same sine. That should happen every time. The cosine of one of the acute angles in a right triangle is the same as the sine of the other one every time, because you're just opposite and adjacent, just switch places. Tangent becomes opposite over adjacent. That's the square root of 3 over 1, which is the square root of 3. Well, that matches cotangent, because again, we switched opposite and adjacent, so there you get the reciprocal. Cosecant, reciprocal of sine. So that's 2 over the square root of 3, which is 2 square root of 3 over 3. It matches secant. So we should think that since these two match, this should be 2, right? Secant's the reciprocal of cosine, and it is 2. Cotangent's the reciprocal of tangent. So I get 1 over the square root of 3, square root of 3 over 3. These are the values right here that very soon you're going to have to just know. That does not mean I want you to go and memorize them tonight, unless your brain just works that way. There's a very few people, but like you just know it now. There are ways in which to learn this and learn how they relate to each other and make it easier. But like I said the other day, you have to be in it to win it with me. When I tell you to practice specific things, you have to do it. So it's a little bit at a time. So right now, when I put this stuff in Quizlet and I send you the little link, right now what you need to be learning are those just the radian measures around that circle, okay? Learn those radians, practice a little bit. It'll make a little bit more sense tomorrow. And every day it'll make more and more sense. And the more you practice, the better off you're going to be. Because there's two things that hold people up in calculus. And the first one is algebra skills. The second one is not knowing their unit circle. Okay, so this is important. And I want you to truly learn it and it not be just this crazy memorization thing. Okay. Do you have any questions for me? Okay. So, you can pass yourself. All right, so go ahead, give this to you. Go ahead and glue or tape this in.